Okay. Let's discuss other topics which are covered in GRE math. Right. So you may even see one or two questions from probability and permutation combinations. Okay. So let's handle these questions. Right. A piggy bank contains exactly 6 dimes and 10 nickels. If 4 coins are selected at random from the bank without replacement, okay, so if you take one out, there must be reduction in the number of the coins in the piggy bank. So because that's not being replaced, the selected one is not being replaced. And the first 3 selected are nickels. Okay, it was already confirmed the first 3 selected are nickels. What is the probability that fourth coin selected is also a nickel? Okay, so 6 dimes and we have 10 nickels. So what's the probability fourth coin selected is also a nickel? Okay, the selected first coin, right? So it was confirmed that nickel meant it must have come from here. So it has already happened. First 3 selected are nickels. It already happened. So right, we will have 9 nickels after selecting one, and then 8 nickels after second, also nickel, right? 7 nickels, okay, after selecting 1, 2, 3, 4. 4 nickels have already been selected. So each have already been, each event has happened. So already happened things, the probability is 1. No need to consider it. So ultimately you have 6 dimes and 6 nickels. The question is asking what's the probability that the fourth coin selected. Okay. 1, 2, 3. Yeah. Fourth coin. First 3 selected are nickels. Okay. 1, 2, and also 3. Then you will be left with 7 nickels and 6 dimes. But the fourth kind should also be nickel, means that nickels should also come from this. 1 nickel from 7 nickels, 1 nickel from 7 nickels can come in 7 C1 ways. When you select, that must be C combination, 7 C1 ways, right? Okay, so these are the favorable outcomes. So the selected coin must be nickel, means it should come from 7 nickel, so that that can happen in 7 C1 ways, right? So these are the favorable chances. But how about the total chances? Total chances means the piggy bank actually consists of 6 plus 7, 13 coins in the, in that particular piggy bank, because already 3 coins have been removed. So the event is selecting 1 coin from 13 coins. So that can happen in 13 C1 ways. So the probability is favorable outcome 7 divided by 13. This is the answer. The event is selecting one nickel, selecting a coin from all the coins, right? For total number of chances. The favorable chances for the event is, one nickel should come from 7 nickels. That can happen in 7C1 ways. 7 by 13 is the right answer. Next, working. Oh, so you know this, right? So for an impossible event, the probability is 0. For a sure event or already happened event, that must be 1. How about this? Of 40 employees at a certain company, 20 are available on Monday to meet on Monday. 17 are available on Wednesday. 8 are available neither Monday nor Wednesday. Okay. What's the probability that a randomly selected employee is available to meet on both Monday and Wednesday? It's absolutely formula based. Okay. So for example, A intersection B, so which gives a sense like both, right? A and B, both A and B is equals to A plus B minus A union B, right? Okay. So there might be total minus neither can also be written as A union B. So you may or may not be given. The total and won't be available on any of the days. That comes under neither. Let's see. 40 employees, certain company, 20 are available. The total we got. So A union B can also be written A plus B minus A intersection B, right? So we'll get A union B here. The total 40 minus neither. Neither means won't be available on any of the day. That is 8. So we got 32. So A intersection B, that's what we have to find. A intersection B is equals to A available on Monday, that 20, and then B available on Wednesday, 17, right? A union B, we got it, no? 32. So 37 minus 32, they are 5. So these 5 people are definitely available on Monday and Wednesday, right? It comes under sets. Okay. Next, the question is, what's the probability that the randomly selected employee must be available? Okay, so the selected employee must be available on both Monday and Wednesday, which means that particular employee must come from this group. So favorable chances are going to be probability, favorable outcomes are 5C1. So the selected employee must come from these 5 members to be available on both Monday and Wednesday, right? So another one, the total number of chances, one employee must come from all, the total 40C1, right? The question is asking for probability, not how many number of employees are going to be available on Monday and Wednesday. So favorable outcomes are 5C1 because selected employee should be available on both Monday and Wednesday, means that person must come from these 5 people who are available are going to be available on Monday and Wednesday. So that can happen in 5C1 ways. The event is actually selecting one employee out of total number of employees, that is 40 employees. So 40C1, 5 by 40 is 1 by 8. So it has not been given as a fraction, so you should be able to write 0.8 ones are 8 twos are 8 fives are, yeah, 0.125 is the right answer. Clear? Numeric entry question, the answer must be directly written in the space in the box provided. Yeah. Alexander flips a coin 4 times. What's the probability that he gets heads on first 2 throws and tails on last 2 throws? Okay, 4 coins. So the probability asking first 2 throws tails, so which means he's asking for TT, and also last 2 throws, sorry, heads on first 2 throws. Heads, tails. This is the probability of the event we have to find out. So this event going to be only one, no? The total number of chances are, 4 times. Fine, right? 2 into 2 into 2 into 2. So going to be 16 outcomes. The total number of outcomes are 16. But he is so specific, 2 heads and 2 tails in the same order. He's not asking 2 heads and 2 tails simply. The question asks 2 heads, 2 tails. Of course, I could interchange HHT, THT, HT, THT, so and so on. But so specific, no? The event is so specific that first 2 throws, 2 heads. Next 2 throws, 2 tails. So this sort of favorable outcome only going to be one. There will be only one event which is in favor for this, because first 2 throws heads, next 2 throws tails. Yeah, 1 by 16. There is only one favorable outcome. If the question asked heads on, okay, what's the probability he gets 2 heads and 2 tails without specifically asking first throws and second 2 throws, then the probability would be higher. The right answer is 1 by 16. To find out the probability of consecutive events, multiply the probability of each event and we, so 1 by 2. He's asking for 1 by 2, 1 by 2, 1 by 2, 1 by 2. So that's 1 by 6. Even you do as such, you are gonna get 1 by 16. The same result, same answer. Griffin has a bag of marble that contains only 6 black marbles and 4 red marbles. If he removes 3 marbles at random without replacing any of the marbles, okay, he has to take out 3 marbles at a random. So this is actually the event. 3 marbles must be taken. What's the probability that all 3 marbles selected will be red? So for this event, you should be able to find out the favorable outcome, right? right? So he for Griffin has background 6 black. We have 6 black, 4 red. If he removes 3 marbles at random, 3 marbles must be taken off without replacing any of the marbles. What's the probability that all 3 marbles selected will be red? So the 3 must come from 4 red marbles, from this group. So the selected must be red. So such 3 must come from the group of 4 red marbles. So then the ways in which 3 red marbles coming from 4 red marbles is going to be 4C3 selection and divided by 3 marbles at a random from the bag, so 10C3. So it's so easy. P of E is equals to 4C3 by 10C3, right? It's 4 by 10C3. So 10 must be written reducing 3 times because we have 3 here. 10, 9, 8. 3 times divided by 3 factorial is 6. So 2 4s are 2 3s are 3 1s are 3 3s are. Four four got cancelled. So we got 1 by 30. Yeah. So we have 10 into 3 here and 1. 1 by 30. 10C3 means 10 into 9 into 8 by 1 into 2 into 3. 1 into 2 into 3 is 6. That was written in denominator. In the denominator. Okay, it's so easy. So the question is asking the probability of the event that all 3 marbles must be red. So this can happen in 4C3 ways. So 3 marbles in coming from 4 red marbles. So in your GRE, you never get this sort of questions. And has a deck of 52 cards. Then these days you are not. The students uh, are not getting these sort of questions in their GRE. No questions from this card system. So because this card system, number of cards, basically vary from one country to another country, but GRE is an international exam. That might be the reason why they are not raising any questions on cards. So you can actually ignore this. No questions from this card system or something. How? These sort of questions are so frequent. It's one of the difficult questions. Try for 1 minute. I'll wait. Yeah, let's do. The probability of rain on each of the 5 days is 1 by 6, except on first day. Okay, there are each of the 5 days. He's talking about only 5 days in a week. So 1, 2, 3, 4, 5. Okay. So each of the 5 days it is 1 by 6, except on first day when it is 2 by 5. Okay, first day the probability of getting rain is 2 by 5. So probability of not getting rain is going to be 3 by 5. These are all for raining. Probability of rain on first day it is 2 by 5. So probability of not getting the rain on first day is going to be 3 by 5. So second, on the last day, that's 4 by 5. So probability of raining on the last day is 4 by 5, means probability of no rain on the last day is going to be 1 by 5. So for the rest of the days, it's 1 by 6, 1 by 6, 1 by 6, 1 by 6. What's the probability that rain will occur on at least one of the 5 days? Okay, at least one of the 5 days means he's asking probability of getting rain on one day, 1 day rain, and 2 days rain, and also 3 days rain. Almost he's asking for all raining on all the days. So he's also asking for 4 days rain. At least 1 day rain means he's asking for rain almost all the days. 4 days rain and also 5 day rain. So this is nothing else. Rain on all the days. Probability of 1 day rain plus probability of 2 days rain, 3 days rain, 4 days rain, 5 days rain. So it's nothing else. Probability of rain on all the days. All days or all the days. Rain on every day. Each of the 5 days. So this can be written probability 1 minus no rain on any day. No rain any day. No rain all the days. No rain on all the days. So 1 minus probability of no rain means I should not get rain on first day. No rain on first day. And no rain on second day. No rain on third day. Bar means showcase, it indicates the complementary probability. no rain on 4th day, no rain on 5th day. Okay, is equals to 1 minus, these are all independent events, so I can write probability of no rain on first day into probability of no rain on second day and all, as they are independent. So getting on rain on a particular day, doesn't depend on the same event on the other day, right? So they are absolutely independent. So let's multiply individual probabilities. So no rain on first day. No rain on first day is 3/5. No rain on second day, that's 1/6 is getting rain on second day. No rain means 5/6. So 5/6. And also 5/6 on fourth day. So 5/6, 5/6, 5/6. No rain on fifth day, that's 1/5. If you simplify, 5 got cancelled, 3 ones are 3 twos are 5. So we get 1 minus 5/72. 1 minus 5/72 is 67/72 is the probability. The last option is the correct one. It's all about understanding the question. You require some practice to handle these sort of questions. Please observe this question. The figure above shows the probability distribution of continuous random variable. It's a continuous random variable y. For each of the 6 intervals shown, the figure gives a probability of value of y. So what's the probability 2? Okay, the probability is asking between, it's a probability density curve. So between 2 and 5, the probability is 0.27. It's so direct, no? 2 less than 5 less than 5. So it's just like probability between 2 and 3. Probability of the event between 2 and 3. Probability of the same event between 3 and 4, 4 and 5. So just add them up. You will get the required probability. Right. So how about this? $51.73.73. You may even do 1 minus these two and also this 1 minus 0.04 plus 0.18 plus 0.05. That can also work. You get the same answer, right? There are 3 drill questions. I'll give you 30 seconds to answer the first question. Please attempt. 1/3 of 75 colored tiles in a bag are blue, 40% of the remaining tiles are green, and all other tiles are white. If one tile is selected, this is the event which gives you total number of outcomes. And what's the probability the selected tile will be white? Yeah, this is the event can give you the favorable outcomes to find out the probability. 1/3 of 75 colored tiles in a bag are blue. 1/3 of 75. 1/3 of 75 are going to be, so the total must be 75. 1/3 are actually blue. 25, and then 40% of the remaining tiles green are 40% of the remaining. So 40% by 100 into remaining means 100 I mean 75. 40% of remaining. So 40% of remaining means 0.4 into remaining 50. 75 minus 25, 50. So they are going to be 20. Green are 20 in number. And all other tiles are white. How about the rest? $75 minus 25 minus 20, 45. So these are actually white. So blue are 25, green are 20, white are 30. So if one tile is selected at a time, what's the probability selected with? So the selected tile must be white. That can happen only when you pick the tile from these 30 white tiles. So the selected tile is white, which means the white tile must have come from these 30 tiles. So that can happen only in 37 ways. Getting one white tile from 30 tiles can happen in 37 ways. That's the favorable outcomes. Right, let me write here probability. Favorable outcomes are 37. The total number of chances, total number of outcomes 70. Out of 75, one must be taken. No? 75 C1. 30 by C1 is the probability. 30 by 75 is the probability we are actually finding out. Okay, 2 by 15 twos are 15 fives are. It's going to be 0.4. Right. Next, four people are playing a card game, a game in which each person rolls is okay. It's not a card game. Six-sided die at the same time. Six-sided die at the same time. Okay. Quantity A is 2 by 3. Quantitative comparison kind of question. A, B, B, C, D. Yeah. The probability that at least two of the people roll the same number. Okay, at least two of the people should roll the same number means at least two people should roll the same number, three people same number, and four people roll the same number, which is again nothing else, 1 minus all different. Right? Yeah. Probability, let's say event, at least two people. So same number, when you say same number, at least two people should roll the same. It cannot be at least one people roll the same number. When there is only one, that's you never compare. To compare, there must be other person. There must be two people for a comparison. to draw like whether they have rolled the same number or different number, right? So greater than or equal to 2. Two people, same number, and 3 people, same number. Sorry. 2 people, same number. And 3 people, same number. Right? And also 4 people, same number. So this is nothing else, 1 minus probability, all different. All different. All different. 1 minus all the people should roll different numbers. So 1 minus probability of getting all different numbers would be 6, no? So for example, first person, he has got a number. For the first person, you can't define, a probability. Because for comparison, first event must have done. So for that, 1 is the probability. Second. So already a number has already been gained by the first person. That number should not be gained by the second person. So the total number of outcomes are going to be 6. 6-sided die means there will be 6 outcomes. 1 was already gained by first person. So the remaining outcomes that should be gained by the second person are 5. 5. Total number of outcomes are 6. Similarly, for the third person, 2 numbers were already gained by first 2 persons. So the remaining number of outcomes are 4. Out of 4, 1 must be, for the third person, 4 by 6. And next, ultimately, 3 numbers were out. Out of remaining 3 numbers, the fourth person should get one of them, right? Yeah. So let's simplify. There should not be P because I have already written the P. Let's simplify this. 3 ones are 3 twos are 2 ones are 2 twos are 2 ones are 2 threes are. So 1 minus 5 by 18. 5 by 18 means 18 minus 5, 13 by 18. This is actually 13 by 18. To compare quickly, let's multiply with 6. So this is in fact 12 by 18. This is 12 by 18 and this is 13 by 18. Which is greater? B is greater. Okay, 12 by 18 means 12 was divided into 18 parts. 13 by 18 means 13 was divided into 18 parts. So when 13 was divided into 18 parts, each part is going to be greater than each part when divided 12 into 18. 13 by 18 is greater. Clear? Yeah. Third question. A bowl contains 4 red marbles and 12 blue marbles. If 2 marbles are selected at random, one after the other without replacement, what's the probability that both red blue marble will be selected? Okay, there is no order which red marble, whether red marble must be selected first, blue marble selected first or something. So let's see. We got 4 red marbles, 12 blue marbles. So the probability is going to be, we have to get 1 red marble. Okay, let's take 4C1 and without replacement. So what? However, we are not picking another red marble. The next one is blue marble. 12. When event has not yet finished, within the event you have to go with a kind of multiplication like this. 4C1, picking 1 red marble from 4 red marbles. So event not yet finished, you have to pick another blue marble from the remaining blue marbles. So within the event, within event, which means between subparts of the event, you have to go with multiplication. If the same event is being performed in another way, in that case you have to go with addition. While we do the such sort of question, you will understand more clearly. For this, 4 red marbles and 1 out of 1 red marble from 4 red marbles, 1 blue marble out of 12 blue marbles. So we got it. And next, if the 2 marbles are selected at random, okay, so 2 marbles from out of 16 marbles, right? 16 C2. This is the probability. So this probability actually covers both the things, first red, second blue. Both the probabilities, like first red, second blue probability, and also first blue, second red probability. Sixteen threes are 48. So we got 2 by 5. Next. So quadratics, of course, you may find at least one question from quadratics. Let's do this. X square plus x minus 20. Okay, the roots are going to be x square 5x minus x. Is it minus x? No, 4x. 4x minus 20. So you should be able to understand x plus 5. So x is equals to minus 5. You're gonna get x is equals to minus 5. X minus 4. So x is equals to 4. So when x is minus 5, b greater. When x is 4, a greater. So the right option is cannot be determined. For x, we have two values, right? When you compare minus 5 with 3 and also with 4, which could be always greater? No, cannot be determined. In the equation shown above, k is a constant. Which of the following is possible value for k? If you check the answer choices, definitely it is, representing the real roots. Let's go b square actually greater than 4ac for real roots. Okay, b square k square greater than 4ac, k square greater than 48. So k must be greater than root 48, or k less than minus root 48, right? Root 48, root 48, almost 6.92 approximately. Less than minus 6.92. So greater than 6.92 means minus 7. Sorry. And then 7, 13. Right? Yes, if you go with minus 13. Minus 12x minus x. Right? If it is minus 7, minus 4x minus 3x. So, sum of the roots. Okay. And 7, 13 can also give the same. If it is 13, 12x plus x. If it is 7, 4x plus 3x. Cool. We got 4 values correct. What's the difference between the greatest and least roots of the equation shown above? He's asking for root 1 difference root 2. So I think you can directly find out. 56 means 14 fours are 8 sevens are 8 sevens are 8 and 7, 8x plus 7x. So it's so easy. X plus 7, x plus 8. X is equals to minus 7 and also minus 8. The greatest is minus 7, 8 is lesser. Difference, greatest minus least, it's 1. Minus 7 is greater, right? Minus 8 is the least. One is the answer. Yes, these sort of questions are also frequent these days in GRE math. If we say x power minus 1 sum a, this equation is going to be a square plus 3a minus 18 is equals to 0. So I think 63. A square plus 6x, 6 into 3 is 18, minus 6x minus 3x, we got minus 18 is 0. So in terms of a, 6a minus 3a minus 18, 0. A plus 6 minus 3, a minus 6, 0. A minus 3 into a plus 6 is 0. A is x power 1, 1 by x is equals to 3. Same 1 by x is minus 6. So x is 1 by 3. X is 1 by 3 or minus 1 by 6. We can we see 1 by 3? No, 1 by 3. Minus 1 by 6? Yes, we have minus 1 by 6. Clear? Next. So we got x minus y is equals to half. So this is half. Quantity A is x minus y whole square. This is 1 by 4. Which is greater? B is greater. We can say x minus y is half. This is x minus y 1 by 2. X square minus 2xy plus y square. X minus y whole square. So it's B is greater. Asking for AB. So a plus b whole square minus a square minus b square can give you 2ab. 30 minus 16 is 14, which is 2ab. So ab is 7. Any doubt? This is 14. We got a drill and quadratics. Which of the following is a possible value of x? X square plus 19x plus 48. Then which of the following is 48, 16 threes are, yeah, 16x plus 3x. So x plus 16, x plus 3, x plus 3, x plus 16 means minus 3 and also minus 16. The rest are wrong. Right, yeah. In the equation x square, one of the roots is 6, then p is the constant. What's the value of p? Just substitute this root. That is root. That should satisfy this equation. So 36 plus 16p minus 18 is equals to 0. 16p is, sorry, it's a 6. Minus 18. That's 18 again. We'll get minus 18. P is minus 3. So easy, right? So this is 5 minus 1. It's 4. 7 minus 2, 5. 5 into 4, 20. These sort of questions are so frequent. They're gonna use, the test maker gonna use a symbol and also gives a meaning of the symbol. What operation that symbol is being used is also going to be indicated, and you should not get confused and just follow it while you solve. For all positive integers greater than 1, x star y be defined as a remainder when x is divided by k. It's remainder. When x is divided by y. Okay. So remainder of x is divided by y. Remainder of x by y. We got 5 by 6. Remainder of 5 by 6. What's the remainder of 5 by 6? 6. 5, 6 zeros are 0. So remainder is 5. Quantity is 5. For this, the remainder is going to be 6 by 5 means remainder is going to be 1. So A is greater. Right? If k is a positive integer, f of k is 3 power k. For how many values k is f of k? Okay. F of k less than 729. Just try to recollect. 3 power 4 is 81. 3 power 5 is 243. Yes. 3 power 6 is 729. Right. 3 power k less than 3 power 6. So these are increasing functions. So no need to worry about it. So just go with x less than 6. Sorry, k less than 6. How many values? Okay, k less than 6 means k can be 0, positive integer. So you should not take 0. Okay, 1, 2, 3, 4, and also 5. There are 5 numbers. 3 power 5 can also work, no? You should not take 6. Because k less than 6 should not be equal to 6. Okay, x is an integer, but here x is not an integer. It's an integer. It's not an integer. So f of x must be 1 by mod x 1 by minus 1 by 3 mod. So it's going to be 3. Answer is 3. Oh, what's the question? Which of the following values of x is f of x greater than? So f of minus 1 by 3 is 3. These are all x values. For which of the values, the right answer is greater than 3. So minus 1 by 4 means, again it's a fraction, so you must go with minus modulus x. You will get f of minus 1 by 4 is 4. So this is actually greater than 3. The question also asking for the x values that can give f of 1 minus 1 by 3, f of x values for which f of x is greater than f of minus 1 by 3. 0. 0 means an integer, so this gives you 1. 1 is not greater than 3, so let's eliminate 3. If you go with 1 by 2, 1 by 2, it's 2 only again, not greater than. If it is 2, you have to go with, it's an integer, x square plus 1. F of x is x square plus 1. So 2 square plus 1, 4 plus 5, 5 which is actually greater than 3, we need it. As per the question, this can also be another answer. Okay, 5 greater than 3. It's not at all an issue of the easier models. Patterns and sequences. Okay, the questions from patterns and sequences sometimes time taking. Okay, if you did the first math section in your real examination really well, the second math section, if consists of sequence and patterns question, that going to be a bit more difficult, an iota of difficult. Okay, right, mostly they are going to be easy. Let's solve this. Which of the following is the units digit of 333? So to find out units digit, it is always necessary to find out the periodicity of the base. So periodicity means how many times in its power the particular number is giving repeated units digits. Okay, for example, 3 power 1, it's 3. 3 square, the last digit is 9. 3 cube, the last digit is 9 threes are 7. Uh, 3 power 4, 7 threes are 21, so 1. Okay, 3 power 5, 3 again, yes. Periodicity 4, the repeated digits are 3971. Oh yes, so 3971 are going to be repeated in this particular sequence. 3 power 1, right? So try to write the power as a 4 multiple. So the nearest 4 multiple for 333 is 332. 332. I mean, to divide, if the number should be divisible by 4, the last two digits must be divisible by 4. So 332 is going to be divisible by 4 for sure. So 4 sevens are 28. 4 eights are 32. Yeah. So still we have 3 power 1. Right? 3 power 332. So 4 multiple. 3 power 4 is 1. For 3 power 4, last digit of 3 power 4 1 means 3 power 4k will also have last digit 1. Okay, if the power is 4 multiple, that obviously has last digit as 1 again. Okay, so how about 3 power 332? The last digit is going to be 1 into 3. So for 3 power 333, last digit is going to be 3. Right. Okay. How about this? In the sequence of numbers above, each term after the first is found by dividing the previous term. These sort of questions are going to be difficult in your real GRE. Okay, so you will always find this phrase, you know, each term after the first, right? Each term after the first means second term. Second term is actually dividing the first term by subtracting b from the result. Okay, it's just like first term. Each term means second term. Second term is found by dividing. So the way I'm explaining you, the way you have to understand, you know, these sort of sentences with these sort of questions. Each term after the first means obviously second term. Second term is found by dividing the previous term, first term, and then you should subtract. For example, second term divided by 20 should be gained. So previous term must be divided minus b. Similarly, 6, 20 by a minus b. So these are easy terms, you know, 6 minus 1 and all. So better to go with the last two. Minus 1, 6 by a minus b. We got two equations. Let's play with these two equations. Plus, minus, plus 7, 20 minus ca minus 6 minus ca. That's 14 minus a. Sorry, 14 by a. 20 by a, 6 minus 6 by a. 14 by a. 7 ones are 7 twos are, so a is, we got a is equals to, if a is 2, just substitute here. 2 means 10, 10 minus 6, 4, b is 4. So b is 4, a is equals to, b minus a is 2. Clear? In the sequence shown above, each term after the first is equal to preceding term plus the constant k. So this is in AP. All the numbers are in arithmetic progression. If the average arithmetic mean A2, A3, A4 is 10. So arithmetic mean of A2, A3 plus A4 by 3 is 10, which means A2, A3, it's not 9, okay. A3, A4 is 30. So let's write down if the initial as there okay, in arithmetic progression, the average of 3 numbers gives you the middle number. So actually A3 is 10. Yes, in arithmetic progression. So if you take any 3, if you do the average, that gives you the middle number. A3 is 10, right? A3 is equals to 10. And similarly, A1 and A5. For A1 and A5, what's the middle number? A1, A2, A3, A4, A5. For A1 and A5, again, the middle number is going to be A3. So that's going to be 10 again. So no need to solve anything. So 10 is the right answer. Right. The middle number in the sequence. Right. The median and the average are going to be same for any arithmetic progression. If the numbers are in arithmetic progression, the median and arithmetic mean are going to be same. Okay. So A2, A3, A4 average is 10. So median A3 also 10. Similarly, A1, A5 average of A1 and A5. So they are all arithmetic. They are all in arithmetic progression. The middle number is A3. That's 10. Okay, we got a symbol again. A inverted triangle B is 1 by 1. Okay, 3 inverted triangle gives you 1 by 3 plus 1 by 4. 1 by 1 by 3 plus 1 by 4. It's 12 by 7. It's actually 0.75. This is 1 point something. So A is greater. A is greater. The next. So we got x plus 14 by 4, 5x square plus 2x minus 10 and f of 5. He's asking for 5. Let's equate these two. You will get a x value. Just substitute in it. When x plus 14 by 4 is 5, x is going to be 20 minus 14. X is 6. X is 6. X is 6. 5 into 36 minus 2 into 12 plus 10. Oh my god. So it's minus 2. 5 3s are 150. 30. 180. 180 minus 2 is 178. And then yeah, this is a bit time taking, but yeah, you can actually finish in 1 minute. The sequence of numbers a1 a2 are defined an 1 by n plus 1 minus 1 by n plus 2, n greater than the sum of first 15 terms in the sequence. So let's write as long as for this sort of question, as long as you won't write the sequence, the sum, you won't get the right thought. You cannot get the right thought. For example, first number n is equals to 1. So it's going to be 1 by 2 minus 1 by 3. Second number to 1 by 3 minus 1 by 4. Similarly, first 15 terms, let's write 14th number. So 1 by 15 minus 1 by 16. Similarly, 15th number, 1 by 16 minus 1 by 17. Just observe what are the terms are going to be cancelled. So 1 by 3, 1 by 3, 1 by 4, 1 by 4, 1 by 15, definitely in the previous term, minus 1 by 15, right? 1 by 16, 1 by 16. Finally, you are left with 1 by 2 minus 1 by 17. These are the terms remain. So 34, 17 minus 2, 15. 15 by 34. This is the correct answer. So there is a comprehensive drill. You can actually attempt them. Okay. So this is the end of the session. We will discuss the next chapter in the next class.